Okay, I've just pulled up a noisy classroom scatter plot. On this axis we've got the class size, on this axis we've got the acoustic rating. Quite a strong linear relationship between the acoustic rating and the class size. And if I were to pull up the R value, we'll do it quickly, 0.89 or negative 0.89. That's a strong correlation or relationship between those two variables. It might be that this value here has been inputted incorrectly, or you simply just want to see how the R value will change by removing this value here, for example. I think that this is probably not the best example to show you, because for me, I don't think I'd have a good reason to actually remove this value. Maybe in the actual internal, there might be a good reason to remove a particular value. Oops, wrong button. Okay, so you may remember from removing values in time series, the first thing, well, in this one, in time series, you had to just remove the last 5 or 4 values. That was easy to find them, wasn't it? You were able to scroll down here and find the last 4 values. When removing a value like this, you actually have to identify it, and it's quite difficult looking for it. All right, the best guess would be the class size is just below 20, and the acoustic rating is sort of just less than 5. So I'm looking for just maybe 19 point something and 4 point something, and I've got to go looking for it. And that's quite difficult on here. If you're looking for that value, it would probably just be a guess. And by the way, it's not sick days that I'll be looking at, it's this axis. It's this one here. So I'd have to go looking. So what I've done is I've just opened up the data in Excel. Okay, very easy to plot in Excel. All you're going to do, highlight that column, hold down Control, and highlight that column. Go to Insert, Scatter Plot, and there's your graph. And there is your data. And if I hold the mouse over that outlier that I want to remove, it tells me what value it is. 4.8, which is just less than 5, and 19.6. That's narrowed the search down somewhat, because I've got to find that 4.8 in this column and 19.6 in this column. If you wanted to add a trend line on here, just right click, add trend line, linear, display equation on chart, display R squared value on chart, or yeah, display R squared value on chart. That's not little r. Remember, little r is the correlation coefficient, so you'd have to take the square root of that number to find. Remember, it was 0.89 in the other one. If I took the square root of 0.78, I'd get 0.89. Just side issue. Now, I'm still trying to find that value, so unless you can think of a quicker way, the way I look for it is I clicked on that column, and then I went to Filter, Smallest to Largest, or largest to smallest, doesn't matter. And if you make sure Expand Selection is ticked, it'll reshuffle everything so that the acoustic rating still matches with all the right values over here. And now I can go looking for 4.8, so all in order. 4.8 is over here, and we're looking for 19.6. It's this row here. And I've quickly found that random outlier that I may or may not want to delete. And on Excel, it's right click, delete, it's gone. Come back up to the graph. Notice that value is missing, that outlier is missing. The alternative to removing a variable would be to go scrolling through here until you found 19.8. There's a 19.8, but it's not it's 19.6. Hey, and 4.8. I found it. Huh, cool. It's row number 97, and that was a complete fluke, by the way. To remove it, 97, filter data, select cases, row number, proceed, row number 97 I want to remove, proceed, and by the way, you have to redraw the graph after that. Acoustic rating and classroom size, and if you come back to here, notice that that value's disappeared. But it was a fluke that I found that the right row number to remove. Hence I've done a quick illustration on how to use Excel. And then you would re-add that linear line. Okay, and you would remember it was negative 0.89? Oops, wrong button. That button. Now it's 0.9. So you have improved that relationship. Oops. You haven't improved the line that you're actually going to use to make predictions. Okay, by 0.01 of a correlation coefficient. So it has strengthened the line a little bit in terms of this would be a better equation to use for making predictions, and that would be your finding.